So we are looking here and finding the area of an oblique triangle. That just means that it's not a right triangle when it says oblique on there. And so one of the things you have to when you're doing any type of testing or anything that we have going on is that you read it carefully and see what you're looking for. Here we're looking for the area, so you're going to implement it in a different way than finding the law signs and the law cosines. So we are still going to identify what type of triangle information you're given. So you're still going to identify whether it's going to be SAS or side, side, side. So that could also confuse you and think that we're doing the law cosines, but we're not. So make sure that you look at the information that we're looking here and they're looking for the area. So in any triangle right now, there is, if we're giving side, angle, side. So if we're given, in this case here, a side, and an angle, notice how this is beta, and so I'm not given B, so it's not the opposite side. So it's going to be that the B, the beta, is in between there. So here we're going to have side, angle, side there for this triangle that's given. Anytime we're given a side, angle, side, we're going to have a regular triangle, and the area of this triangle is going to be 1/2 base times the height. But the height, it's not a right triangle, so I can't just find the height that way. So I have to use some information with trig to be able to figure this out. So here's a triangle where we have A is 4.2, C is 5.7, and the angle is 62. So let me try to explain it a little bit with what we have here. So the first side is going to be 4.2, the second side is 5.7. So that's this side right here, and then that's this side right here. And then we're given the angle beta, or in this case I call it theta, but that's the beta on there. So if I have this, we're not given this side and we're not given that side, because in the other one we were given that A and C and then beta. So that's the angle in between. So in order for me to find the area of this triangle, we are going to use the 1/2 base times height of a triangle, the formula for finding the area of a triangle. So I have to find the height because, and I have to make one the base. Now it doesn't really matter whether I make this the base or this the base, this the adjacent side or that the adjacent side. I just have to choose one. So in this program that I created, I actually chose one. So I click on the height and I said that this here is now going to be the base because the height is falling against it. And so therefore this here has to be the adjacent side to the given angle. So if I look at this, in order for me to use and find the height, because it doesn't look like it because it's kind of skewed there, but the height always forms a right angle with the base, and it does form a right angle here. And so I could do the SOHCAHTOA. So this here is a right triangle. So I do, to find the height, I do sine of this angle is equal to opposite over hypotenuse, because this is opposite the 90-degree angle. So it's opposite over hypotenuse. And then I solve it just like we did when we did the law of sines. And so now we have the adjacent side. So this is this side if I solve for h, and then the sine of that angle. Once I do that, so I put in 5.7 here, and then the angle of 62, it tells me that the height is 5.03. So that's the height there. So in order for me to find the area, let's go back and try to figure that out. So I am going to find the area. I know what the height is. We said that it was 5.03, blah, blah, blah. And we said that the base, if we look back on that, again, the base is where it's falling in there. So this here is your base. So that's 4.02. And so this base here is going to be 4.2, not 0.2. So we have this multiplied times that, and we have half of that, and then we find the area. So when I calculate these two, and then this one here, I would store it so that it's the whole answer of the height down there, not just the rounded off area that I have there. But when you calculate it, you get that the area is approximately 10.57, and then area is going to be unit squared, so it's going to be meter squared because you have meters here and meters here. Multiply those together, you get meter squared. Now let's go back and see if that is the correct answer. So we're going to go back here and put in the area, and the area is 10.57. If it is correct, then the triangle will turn a light brown. So when I hit enter, it did turn a light brown. If I were to, and it says 2 decimal places. And so if I just hit that, notice how it's not light brown, so therefore it is not going to be that. But then I changed it, and then therefore it is. So by 2 decimal places, we found the area of this triangle. This is a side angle side situation, and that's how you find it. Anytime you have side angle side, you have to find the height, and then you do 1/2 base times height. And so we're good on that. And so let's go on to the next problem. Now we're finding the area again, and so we're doing the area right there. But now we're not given an angle. We're given side, side, side. So how do I find when I'm given side, side, side? Well, this is what they call Heron's formula. So Heron's formula is given some information. It looks kind of difficult, but it really isn't. So we're going to say Heron's formula. And so what Huron's formula says is that I have to find out what S is. It's not a side. So I know that they're using S. So in Huron's formula, we say that we have S there. And then that S, and I'm going to explain it better over here with this on that. I'm going to get rid of this area there, hit enter. And I am going to go this one here so that we could see. So this is area of a triangle, side, 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 and we want to know Heron's formula. So here, this is Heron's formula. It uses this S. It is not a side. This S is found by the sum of all the sides of the triangle that are given. So you are going to add side 1, side 2, and side 3, and then half of that, so you're going to divide it by 2. So that's what your S is. And the formula, this is your Heron's formula, the area of any triangle that is given to you only the sides, is that you take this S right here, and then you're going to multiply it times the difference of the S minus one of the sides, the S minus the other side, and the S minus the third side, and then the square root of it. So the triangle that we were given there in the previous page, we said that one of the sides was 5, the other side was 9, and then the third side was 10. So we have this triangle right here. And so that's the third side. Let's try to connect this right there. Very, very close. So we're good. Let me move that up there. Oops. So okay, so that's the triangle that we have. We're given all 3 sides, and so we're going to use this formula to figure that out. So going back here to show the work, when we have the Heron's formula, we're going to find S. Well, we know that we have 5 plus 9 plus 10 all divided by 2. So when you calculate it, then you're going to get your S to be 12. So that's what S is. And then we're going to put it to find the area. So the area is going to be the square root, and we're going to take 12, and then 12 again subtracted from the A, which is 5, and then the 12 subtracted from the 9, and then the 12, and then subtracted from the 10. And then we calculate that, and so we end up with once you calculate that and take the square root, we end up with 22.4499 centimeters squared. So the area of this is going to be approximately 22.45. Let's go back and check and see what we get. So they're saying that the area here is going to enter the 22, and it's 2 decimal places. So I'm going to do 0.45, and if we're right, it's going to turn light brown, and it is. So that's how you find the area of a triangle using Heron's formula, and you can only use Heron's formula on side, side, side. Notice how we're not finding the height or the side opposite because we're not given any angles. We're only given the sides on there. And so that's how you find the area. You're only going to be given 2 cases, the side angle side or the side, side, side. Okay, so now let's go back and let's apply it to a word problem. So a parking lot is to have the shape of a parallelogram, which is what's given right here, that has adjacent sides measuring. Okay, so everything's on here. There's an angle that's given to 65. What is the area of the parking lot? So what we're going to do is actually it's a parallelogram. We're going to divide to something we already know, to a triangle, because that's all we've been dealing with is triangles. So we're going to take this and we're going to make it into two triangles. I want to keep the 65 in there. And then we have this triangle that looks like that. It's an oblique triangle. And so therefore, we are going to be able to solve it either using the area is half base times height or the Heron's formula. Because we're given side, angle, side, and if you notice here's a side, the angle on the side, we are going to be able to use the area of the triangle, which is 1/2 base times height. So where are we going to draw the height on there? So because we have the angle, we want to have that angle included. So we're going to use this one here or this one here to actually find the height on there. And the one that we are going to use is we're going to drop it. In this case, we're going to drop the height. I should have done that in a different color, but I'll do this in purple. I'm going to drop this here and it's going to form a right angle right there. So this here is going to be my base, and so this side here is going to be the hypotenuse because it's opposite the right triangle right there, and so that's going to be the opposite there. So if I'm going to write down, find the height, this is the hypotenuse is the adjacent side in this case, and so we're going to do 200 feet, and then we are going to do the sine of the angle that's given, which is going to be 65 degrees. When I calculate h there, that is going to give me approximately 181.262 feet. I stored it in my calculator so that I could calculate it here. The base is where the height is actually falling to, and so therefore that's going to be the base. So it's going to be the area of the triangle is going to be 1/2 the base, which is going to be 260 feet, times the height, which is going to be 181.262 feet there. And so when I calculated and I used my stored info on the height, it turns out that we are going to get approximately 23,564 feet squared. So we're going to have that to be feet squared. Now, did I have to calculate it with the 1/2? And the answer is no, because this gives me the area right here. So it gives me the area of this triangle right here, but the parking lot is two of them. So if I have two triangles, I need to find the area of both triangles, and they're exactly the same triangle because it's a parallelogram. And so instead of dividing this by 2, I could multiply this by 2, and that would have been an answer. So I could have done that. But since I did divide everything by 2 and I got 23,000, and now I could find the area of that triangle by multiplying that by 2 because that's going to be there. So when you multiply that, because you have two triangles, the area of two triangles, I am going to get approximately 47,128 feet squared. And so you would write your sentence, the area of the parking lot is 47,120 feet squared, and that's how you solve this problem. Very good. Okay.